Hi, welcome back for another 8 Caillou challenge. This is called Beginner Series number 2, Clock. And so the clock shows hours, minutes, and seconds after midnight. Your task is to write a function which returns the time since midnight in milliseconds. They show an example with 0 hours, so this would be 1 minute and 1 second after midnight, and the result is 61,000. And so you have to figure out how to do this in the general case. They assure you that the input will be valid. You could check that if you like. I won't for this challenge. But the hours will be between 0 and 23, minutes between 0 and 59, and seconds between 0 and 59. So you don't have to worry about the seconds containing minutes, the minutes containing hours, and so on. So, pretty clear here. There's a bit of math involved here, so you have to figure out how to get this result given those values. If you need a hint, figure out how many milliseconds are associated with each time denomination here, and then you can multiply that by the number of seconds, minutes, and hours that you are provided. I will get into it. I'll give you a chance to pause while I format here, and then we can get started. So let's go ahead and do like what I was talking about. So we're going to be caps. Don't mean to yell at you this morning. So we see the answer is going to be something like this. It's going to take the form of the hours that were given times, I'll just put an underscore. It's going to be the number of milliseconds associated with 1 hour. We're going to add that to the minutes times the number of milliseconds associated with minutes, and then we're going to add that to the number of seconds we're given times the number of milliseconds in a second. And hopefully you know the prefix milli means 1,000, so I'll just go ahead and put that in for now. So the question is, how do you get these values for minutes and hours? Well, how many milliseconds are in a minute? If we know 1,000 are in a second and there are 60 seconds in a minute, you could do 60 times 1,000, right? I'm just using parentheses here to group these quantities. I don't need them strictly, but I'm just trying to keep this organized visually for you. And then you can do the same thing with hours. So you could say, how many milliseconds are in an hour? Well, it's going to start out just like this, right? We're going to say we have 1,000 milliseconds per second times 60 seconds per minute, and then we know there are 60 minutes in an hour, so I get this quantity. And if we run this, I would expect this to work out. We're going to clean it up, but I just want to show you how you can kind of build into the answer. Green start is good. Okay, so we have it. And so of course you can combine these constants, right? You don't have to break it out into all these separate multiplications. You could say 60 times 60 would be 3,600, right? And if you multiply that by 1,000, you can just add the 3 zeros here. I can get rid of that. And then 60 times 1,000 would clearly be 60,000. And so this reads a little bit better, right? Same difference, we're just condensing it. And then, in the purpose of best practices and to make this not an entirely math problem, let's add some coding concepts here. So often what you'll do is make constants for these. We don't like to use so-called magic numbers where you'll be running into code and there's some value like this and it's not clear where that value comes from. Here, you know, people could figure it out with hours, minutes, and seconds, but let's just do this for the purpose of showing best practices. So I'll say private static read-only int. Got to give it a name, so we could do something like this: milliseconds per hour. And it's common for constants like this to be in all capital letters with underscores filling where a space would go. If you want to write out milliseconds, you can. It makes a name long, but that's okay. Read only, you can't change the value. It's a constant. That's why I did that. And so we can just enter our values here, and I'll show you what the effect is. We'll do this, and we'll copy this a couple. Well, actually, just Yeah, I suppose we could do it 3 times. And then we'll do milliseconds per minute, milliseconds per second. It was 1,000 and 60,000. And so the effect that you get is something like this. We'll get milliseconds per minute and milliseconds per second. And so the idea here is that this becomes more readable, right? You can see it's hours times the milliseconds per hour, minutes times milliseconds per minute. And you can see that you're converting these into milliseconds. And it's a little more clear when you take a quick peek at this, what it's doing. There are certainly better examples where using this approach will be more beneficial, but I wanted to show you the practice, so it's there for you. When you come back to your code after a long time, you don't have to remember why you multiplied by wild constant numbers. So I'll go ahead and submit this. We got to run the test again because we changed the code, and I got the green. So I'll go ahead and fire mine off. This way it's a little extra typing. I imagine nobody else did this. Maybe we'll get one of those best practice votes though. Reads really nicely, right? Submit it off, get those points. Okay, that's cool. They use the time span here and use that to just access the milliseconds right away. That's a really nice solution. So if you're not familiar with time span, you might want to look into that. That's cool. So yeah, pretty similar stuff going on here. Feel free to look through these at your leisure. Otherwise, you know where to find me with those questions and comments. I think I will leave it at that. I will see you in another video. Thank you for watching.